Hi, welcome to my first Houdini tutorial. This is a tutorial which will be like a quick start where we'll be giving you a overview of what the Houdini interface is, as well as having a small project on a particle fluid splash. Right. To start off, this is your viewport. You can shift between your viewports by coming here to set view, perspective, top, front, right. You can see the shortcuts as well as given here 1, 2, 3, 4 and 5. Now these are your transform tools. This is your move, rotate, scale. As you can see, the shortcuts are T, R and E. Mouse middle button drag allows you to rotate the viewport. Sorry, mouse left click drag allows you to rotate the viewport. Mouse middle button drag allows you to pan, and right click allows you to zoom in and zoom out. You can always zoom in, zoom out using your scroll button also. To start off, let us add a small sphere to the screen. So add a sphere here. Okay. Now I'll move this sphere up on the y-axis because I wanted to fall down to the floor wherever I'm going to splash it. So I have taken this up on Y, and if you open Windows and add a new panel here, this panel will show you your network editor. You can get it over here also by opening up a pane here, but I find it always much more comfortable by opening it up here. Press L and it will arrange the object onto your network editor here. So if you see, this is my sphere object 1 which has come up. Okay, if I double click on this, I go into my sphere's sub-object focuses over here. If I click on object level again, I come out of it. This is to hide or show the output of my node. Now I need to reduce the size of this sphere. This can be done in two manners. One, I can always come here and scale it down where the scale is coming as 1, 1, 1. I can use the scale tool here, or at the same time I can go into sub-object level here and change the radius. You can see we've got individual radius for all the three axes. So I'm going to bring this down to 0.5. I'm just pressing tab to shift to the next entries, and I hit enter. So you can see that my sphere has gone down in size. Now once we've done this, I'll come back to my object level. So here I've got the sphere here. Now I need to populate this using a particle fluid. So to do that, I'll come to particles here. You've got this flip fluid from object. As soon as I click on flip fluid from object with my sphere selected, it is going to take the surface of my sphere as an input and populate particles all over that surface. So it creates, in the end, creates something like a droplet. So with my sphere selected, I am going to click on flip fluid from object. It takes some time to calculate. You can see here the calculation goes on. Yep, it's come. Now I'll just zoom onto the screen here. You can see that this sphere is covered with these small spheres. Now let us come to our network and see what new has got added. I already had my sphere object here. I've got this auto DOP network. This auto DOP network is actually going to connect your objects into the dynamics module. Now I've got this sphere object 1 fluid which is actually generating this fluid here, and this is sphere object 1 fluid interior. Let me just double click on my sphere object fluid and press L again to get this. Here, yep. So yeah, sorry, if you double click on your auto DOP network, this is, you're going to have this flip fluid object 1 here. Click on flip fluid object 1. I'll just minimize this. Now come to guides. See, here it gives you the initial data about how this surface is taking its input type as surface. Come to guides. This is where it will tell you how this entire fluid is being visualized onto the viewport. So if you come to particles here, you can see now the visualization set type is set to sprites. We all know what sprites are. If you just toggle down the scale, you can see that the size of these particles go down. So sometimes there might be situations when you find these particles, all of them together get a bit difficult to watch and difficult to analyze. You can always change these sizing from here. If you scroll down below, you will find this visualization type is speed. Now the color of this fluid for the time being is being controlled by its speed. Visualization mode is ramp. You can see the ramp here. So that means as and when the speed of this particle is going to, this fluid is going to increase, the color is going to change in this direction of the ramp. So we can just play this and see the color has changed immediately, because as soon as this particle has got certain velocity, automatically the color has started changing. Alright, so that was about your fluid node here. Now let's come back to my object network here. Yeah, so we've got this scene here. Now obviously we need to create a floor where this particle fluid is going to go and splash. So to do that, I'm going to take a box here, okay, and I'll quickly come to my network here. You can see this box object has come up. So I'm going to go inside my box object. Similarly, like we had for radius, I've got the size here, size 111 has been mentioned. I'm going to shoot this size up to somewhere around 6, 6 and 6. Okay, that's my box, and I'll come back to my object level, select the box. It's already selected. My transform tool is also selected, so I'm going to just move it up. You can toggle between wireframe and shaded mode by pressing W. If you press W, you can toggle between your wireframe and shaded mode. You can do the same thing from here by clicking here. You've got wireframe bounded box or shaded bounded box. You can do it from here also. Right, now what we need to do is we need to delete these 3 faces, so that I get another 3 faces where I can see inside the box. So what I'm trying to tell you is, I'm sorry, I went into the tool. Okay, what I'm trying to say is, see this box, I need to delete this face, and this face, so that these inner faces are visible to me. Alright, let's come back to my network. Yes, I've got the box selected. Let me just double click on the box here. Okay, when you double click on the box, here you've got points, edges, primitives. If you select primitives, you'll be allowed to select these faces individually, right? Provided your focus is already inside the box. So I'm going to select these 3 faces and I'm going to delete it. Now as soon as I delete these 3 faces, what happens? If I come to my network, you can see I have got a blast operator which has got added. A blast operator, what it does is it breaks up the geometry and you're allowed to delete or work individually with the faces. So this is more or less done. I'm going to come back to my object level here. So keep this selection at primitives. Alright, yeah. So I've got the box selected here. Now I need this box to interact with this particle fluid here. For that interaction to happen, this box has to be a rigid body. Now if I have to take this as a rigid body, because only then it will come inside the solver to start working. So if you come here, you've got a rigid body called static object. Now what happens when it is a static object is none of the forces or the fields will start affecting this. Like for example, if I just come to my DOP network and I just go into my DOP network here, you can see there's a gravity node which is added by default. Okay, now if I'm going to take a static object, what happens is it will go inside the DOP network, but the gravity is not going to affect my object. So I'm going to, sorry, I'll just come out of the focus here and take my box again and click on static object here. So what happens now? Not much has changed if you see, but if I double click on my box here, you can see I've got a DOP import here. This is where the box is going to take the data of dynamics from this node. Alright, now one more interesting thing that we can see here is if you just go inside your DOP network, you've got this static box object here. Okay, now one more trick, there are times when you might find that this network looks a bit jumbled. So all you need to do is press L in your keyboard to arrange it properly. Okay, L in your keyboard arranges the entire network, fits it into your screen. So with this box object selected, let's come to this now. Okay, before we go ahead, let us do one more small activity. Let's hide this box. Box got hidden. Yeah, let's come back to my DOP network and double click. I take my box object here. Here is where I'm getting the properties. Now see, it's saying display geometry, so I hide the geometry. I don't want to see the geometry. Come to collisions and scroll down. You find this option here called show collision guide geometry. Now this is very important when you're trying to have interactions or collisions with a particle and a static rigid body. Now if you remember, we had deleted 3 faces from the outside of my box. So what I'm trying to show you here is this collision is a volume based collision detection. So if I switch on this show collision guide geometry, I do not see any geometry. Why? Reason being, my object does not have any volume. So let's select this box object here and let's unhide this. Let's come back. You see, it doesn't have any volume. These are just planes here. So I need to extrude these, okay, so that I can add some volume to it. So again, for extruding, what we need to do is let's just go inside your box object. Now see, this is again one of the best features of using our Houdini's procedural networks. Is if you see that this is I've got a blast one here and I've got a DOP import here. Now I need to connect my extrude node between these two. So what do? I click here and drag. You can see the silver thread which is following. Keeping that like that, I press tab, which opens up all these nodes which I can add. So I just type poly. Something went wrong. Hit escape. Just tab again, and I type poly extrude. Yeah. Okay. So I take poly extrude here. You can see this outline following my mouse. Left click on the screen and poly extrude has come. Now you can see this showing this reddish here because there's some input which is missing. So what input is missing? Now you have to tell this poly extrude node what to extrude. So obviously my blast has got these 3 faces which I need to extrude. So I'm going to click here, left click and drag. Okay. So my poly extrude has come. So I'll just translate this extrude on the Z of grounds of 0.5. Now you can see this, I am seeing the extrude which has come up, but I am able to see it only in the outlines. See that? These outlines, I am not seeing it in the shaded format. Again, because this is off. Switch this on, I am able to see. Okay. Now, after this, we need to just do one more order of business here. Yeah, you've got switch on this output back so that Houdini starts recognizing both the end of the surfaces. Right? That done. Again, I need to connect this to my DOP import. Otherwise, my DOP import is not going to understand. Let us just take a sample of what happens here, because you can see blast one is connected to DOP import here, and my blast one is connected to poly extrude. What happens here? See, I have added extrusion, I have added volume, but if I come back to my DOP network and I select my box object here and I scroll down and show collision geometry, you can see it's still empty. This is visible because of my box. Let me just come back here and I hide my box now. Now see, with collision geometry on, still doesn't show anything, right? That is because we have extruded it. No problems, we have extruded our box, but the DOP import node does not know that these faces have got extruded because it comes and ends here. This node has to be connected to our DOP import. So what do? I just left click here and click here. Now you can see it goes into blast, goes into poly extrude, comes to DOP, right? So let's come back, let's hide the box now, and let's again go to our DOP network here. Now you can see with my show collision geometry here, I'm able to see these three volumes, but there is certain gaps here. You see this? Why? Because if I go back to my model, see, we've got these problems here. You see it now? These edges here, so they also need to be again here, because here it is connected again in a single plane. So that is why the collision, the rigid body solver is not able to, get those collisions. Okay, let's just come back to my box object here and go to my extrude. Now here, if I just come to local, you can see my local symmetry key point shared is set to no. Let me set it to use normals. As soon as I set it to use normals, you can see that that problem which we had earlier has got rectified. Now let us again go back once and visualize on how it's looking. Let's just hide my box here. Yeah, now you can see it's pretty clear. There are no longer any sort of gaps as far as the simulation is concerned. Let's come back, unhide my box. Okay, hit a L, just get this arranged. Yeah, so this is ready for simulation now. I'll just hit a play. You can see the color of this changing as the velocity changes. You can see the splash which comes once the particle fluid has connected with the box. So we'll render up to, we'll just simulate up to around 37 frames here. We can stop here, 38, we stop at 38. Now automatically this entire simulation has got cached. So if I play now, plays real time, I think the caching has somehow missed out. Stop this for a minute. Let's rewind this. Seems to be some issue with the. I'm just going to pause this video for a second, and we'll come back as soon as we have rectified this. Okay, we've solved that problem, right? So we were simulating this. We were just solving the simulation. Let's just play this now, and splashes. Stop here at frame 37 and just rewind it back. Okay, so playing this now, you can see it plays smoother now because the simulation has got cached till frame 37. After frame 37, it's going to again see it stops at 38 because till 37 it was cached, and it starts again calculating the solver. Alright, so once we've done this, let me just rewind it back. Now what we need to do is we need to get an output of what we have done. So first and foremost, to render in Houdini, you need to add a render node called mantra. So you come to render here, create render node mantra. Okay, now once this mantra node is created, if you come to your network view, you will not be able to see the mantra node in your object level. You will have to come to output level to see this mantra node, right? So let me just come to mantra here, and obviously we'll if you see here, it asks for a camera, so we need to take a camera here. Let's come to lights, and now if you simply click on the camera, you will be getting a camera object which you can place anywhere on the scene. But If you control click on the camera, what happens is automatically you start looking through the camera. You can see your perspective 1, cam 1. So I'm going to set this to a satisfactory angle where I can see the entire details. Now once we've done that, I'll repeat that same process using a spotlight, because I would like to add some light to the scene. Or if you don't want to add some light to the scene, it's fair enough. It's your call how you are going to render it. Let me come back to my mantra node, and here it says render any frame. Before I go into render any frame, I will go to render frame range. Start 1, I would end at somewhere around 37. Okay, and properties, here you get all your render properties. We'll be having a different lesson where we'll go in depth on rendering using mantra. I want some motion blur, so I'm going to just switch on motion blur. It's going to be a very generic render. Once this is done, and yes, one more important thing I think missed out. Let's just come back to object. Now what happens is, if you want to take this file somewhere, you just click on dop network. Here you can see that it is caching your simulation. Okay, your cache memory takes as 100 MB. That is what had gone wrong earlier, when it went very sluggish, because the cache memory, it took more than 100. Now the problem here is, if I shut down my Houdini and if I reopen it, I'm going to lose out on this cache. So I want to save this entire simulation into a file. I can do that very easily by clicking on my DOP network here, and okay, in switch off these collision geometry, we don't need to see that. Right, go into DOP network here, and here if I just I pressed L and it all gets arranged. Now you can see the last node out of my DOP network is gravity. Now for adding a file cache, it has to be added after the last node. So what I do is, I press tab and I type file. You get the file node here, and drag the file outline here. Just connect your file node with your gravity with the file node. So this is the final network that looks at. Now here you can see it says baked $sf4.sim. So we need to set up a file where I'm going to save this. So I'm just going to go back to my tutorials folder, and I'm going to add a new folder called Houdini cache 1, and here I can give any name. I can give, let's say, my drop cache, but what I need to maintain is this $sf4, because what this does is, $sf4 is basically a variable which is going to add the frame name to your cache file. So I save this as like this, and it saves as .sim file. Click on accept. We need to switch on this, because this is going to activate my node here. And let me just come back to my object level. I'm going to play now. Right, it's playing. In the meantime, you can always come down to D, and where Houdini cache 1. Okay, it's not caching. No, just stop this. Let's rewind it. Come to my DOP network. Your file is on object. Let's cache it again. Seems to be some issue. We just, again, I think there's been an overflow with the cache memory. We'll just pause this for a minute and just come back. Alright, the problem that was coming up is, if you see here, it's set to no operation. Operation mode is set to no operation. So we need to tell them that you need to write these files, right? So we set this no operation mode to write files. Let us rewind and let us play. So it calculates, and obviously it's going to be significantly slower this time, because obviously it is writing these files onto my disk also, right? So we'll just pause it for a second and come back. Yeah, so we've simulated right down up to 38 frames here. We'll stop the simulation here. You can see here these files have been made. Okay, so we've cached the files. Let's just rewind here and hit play now. You can see it's significantly faster again because it's no longer simulating, right? So okay, so we've added our files here. Now we can go back to my mantra node and just see how this render comes up. Let's come to output mantra 1. I've set up my render frame range. I click on render and my player starts. So we'll just wait a couple of seconds for this to come up. I'm going to pause again so that you don't have to wait for this entire rendering to complete. We'll just come back once the frame has been rendered. Right, this is how the first frame looked. Okay, it's going to start rendering the second frame now. What I'm going to do is I'm going to jump directly to frame 36 or frame 37 so that you can see the splatter now. So just pause it once again. I'm going to change this to 36 and I'm going to hit a render once again. It shows you how frame 36 is going to look at. Again, it's going to take its own no sweet time, so I'm going to pause this again and jump direct to the end. Okay, this is the last frame where this has been rendered. Okay, so it started rendering on the next frame. So you can see the splash quite clearly. Now this was a very basic and a fundamental lesson on how to start off with Houdini and how to take a look at its own particle systems. Now before I just wrap up on the lesson, because we'll be continuing a new slew of lessons on Houdini shortly. The next lesson will be on how to work more with our particle fluids. As many of us working as faculties, we find it sometimes difficult to correlate with this kind of a interface. Honestly, this network editor which Houdini has is one of the most powerful tools with which we can work. So all the best guys, and thank you.